So the question is, if you take any quadratic equation, and what a mathematician does to develop a formula is starts off with any quadratic formula or any quadratic equation possible. So we use the letter A, B, and C. They could all be numbers, any numbers possible. And they say if I could solve it for a different question, if I can do it with numbers, I should be able to do it with variables. I just have to follow the same steps. It's a little bit more difficult because you're not dealing with numbers every time, but the process is the same. So do you remember on the black side here, if we wanted to solve this, and this one can't be factored nicely to work out, if we wanted to complete the square, maybe I'll just change this just to make sure that it works. I think it would have worked, but I'll change it to -5 just to make sure. If we wanted to solve this, what was the first thing that we did? Okay, we divided everything by the 3, right? So if I divided everything by the 3, I would have got x squared, keep it in black here, x squared plus 12 divided by 3 would be 4x minus 5 divided by 3 equals 0. So now on my quadratic equation side, here I would have to divide everything by, if the first step was dividing everything by the 3 because we wanted an x squared by itself, here we have to divide everything by a. So I get an x squared by itself, I'd have b divided by a, and I'd have c divided by a, and 0 divided by a is still 0. On the black side, what was the next thing that we did? Created a space, right? Moved the 5/3 over to the other side. Created a space on both sides. We'll do the same thing here. Subtract c over a on both sides and add a space. How do I figure out what number goes in the space on the right side? Took this number, divided it by 2, and squared it, right? So 4 divided by 2 is 2. Squaring it becomes plus 4. Maybe I'll write that in green. We add 4, add 4. Now, with numbers, this is especially a step that's a lot easier. With variables, what happens when I divide it by 2? 1/2 of that, so you'll get b over 2a, and then we're going to square it to go into there. Because that's half. Half of b over a would be b over 2a. And if I square it, I'm going to get b squared over 4a, and I'm going to have to do the same thing here, b squared over 4a. Because b times b would be b squared, and 2a times 2a would be 4a squared. Whew. Close. Good thing we checked that. On the black side, we now could write this as x plus 2 squared. And on this side, in order to put those together, we'd have to add our fractions. We'd have to get a common denominator. 4 would be 4 over 1. So I could change that to 12 over 3. 5 over 3 plus 12 over 3 will be 17 over 3. Same thing on the left side. Just going to erase this. This side will be x plus b over 2a all squared. Because we always notice that this number, this 2, was half of 4, so this b over 2a is half of b over a. On this other side, in order to add those together, we're going to need a common denominator. On the bottom of the one is 4a squared. On the bottom of the other one is just a. So if I multiply this first fraction by 4a on the top and the bottom, I'll get 4a squared as a common denominator. When I add the tops now, it's going to be all over 4a squared. I have negative 4ac plus b squared, which is the same as b squared minus 4ac. And I'll write it that way because that's getting close to my formula. Okay? Start to notice I have something b squared over minus 4ac that I want in my formula in the end. The next step was square rooting both sides. So when we square root this side, we get x plus 2. We remember the plus or minus. Square root of 17 over 3. When we square root both sides over here, we get x plus b over 2a plus or minus now, this gives us a square root on the bottom, right? Because this is the same as that, right? And on the right side, we'd have to make sure we don't have a square root on the bottom. The nice thing on our formula side here the top is going to be b squared minus 4ac. The bottom, when I put it in a square root, it's a perfect square. What's the square root of 4? 2. What's the square root of a squared? A. So on the formula side, we already got rid of our square root on the bottom. On our non-formula side, we would have to do an extra step. This step where you rationalize the denominator isn't needed on our non-formula side. And finally, to get x by itself, here we would just have to subtract 2 on both sides. And here we'd have to subtract b over 2a. When we want to write our answer, the best way to write our answer is a single fraction. Here, this is 2 over 1. There isn't a common denominator, but you could get a common denominator because you can make negative 2 over 1 negative 6 over 3. And then you could get a common denominator here, negative 6 plus or minus square root of 51 all over 3. Here we already have a common denominator, so we get negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we started with a general equation, ax squared plus bx plus c. We solved it by completing the square, and we come up with a formula. What this means is we can now solve any question by just plugging things into the formula. So if we go back to this original question that we just solved, 1 plus the square root of 3, we could have done this one with our formula. According to this equation, with it equal to 0, the a value would be in front of the x squared, so you can see that a would equal 1. Your b value is negative 2. And your c value is another negative 2. So to solve it using the formula says negative b, so you plug in negative 2 where the b is, plus or minus square root of b squared minus 4ac. Just plug those numbers in, all over 2 times a. And if we simplify everything that we have here, we're going to get negative 2 is positive 2, plus or minus square root of negative 2 squared is positive 4, minus 4 times minus 2 is positive 8. 4 plus 8 will be 12 over 2. Now, the answer that we got when we completed the square was 1 plus or minus square root of 3. Right now, we've got 2 plus or minus the square root of 12 over 2. We always have to simplify things as much as we can. The square root of 12 simplifies to 2 root 3, all divided by 2. And maybe you can see that you can divide both of those by 2. Maybe you want to factor out the 2 in front. And then your 2's will cancel. And we do get exactly the same answer using our formula. I can scroll back up. Is that far enough?